Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is kth smallest product of two sorted arrays. Now the problem category is of hard level, but I would try to make it as simple as possible. The input given in the problem are two sorted arrays, nums1 and nums2, and there is another input which is an integer, and let's call it as k. The output we need to give in the problem is the kth, this k is coming from the input. So the output we need to give is the kth smallest product of nums1 of I multiplied by nums2 of j. Now let me clarify that what's the output we need to give. We need to find what is the kth smallest product of nums1 of I and nums2 of j. This I and j are the indexes in nums1 array and nums2 array. So we need to choose some index I and some index j from the array nums1 and nums2, multiply the elements at those indexes and return it if that product is the kth smallest product. Now let me try to explain you the problem using some examples. So let us say the example number 1 is the nums1 array is 2, 5, the nums2 array is 3, 4. Both the arrays are sorted, right? And the value of k is equal to 2. Now this k equal to 2 means that we need to find the second smallest product out of all the products which are possible. Now what are all the products I am talking about? You can take any element from nums1, another element from num2, multiply it and get a product. So the indexes are 0 and 1 in both the arrays. I can say 0, 0, the index 0 in nums1, the index 0 in nums2, 2 multiplied by 3 is 6. Then I can say index 0 from nums1, index 1 from nums2, 2 multiplied by 4 is 8. And similarly, I can say 5 multiplied by 3 and 5 multiplied by 4. It's basically multiply all the elements of nums1 to all the elements of nums2 one by one, get all the products. So 2 multiplied by 3, 2 multiplied by 4, 5 by 3, 5 by 4. The products are 6, 8, 15 and 20. You need to find the second smallest. The second smallest is this one. This is first, this is second, right? So the output in this particular input will be 8. Another example is in which negative numbers are also involved. When the nums1 array is -4, -2, 0, 3, nums2 is 2 and 4, then the different products which are possible is 2 multiplied by -4 is -8, then 2 multiplied by -2 is -4, this 2 multiplied by 0 is 0, 2 multiplied by 3 is 6. Then you can say 4 multiplied by -4, 4 multiplied by -2, 4 multiplied by 0 and 4 multiplied by 3. So the products are -16, -8, 0 and 12. You need to find the sixth smallest product which is there. So the smallest is -16, 1, then 2, second smallest, the third smallest, fourth smallest, fifth smallest, and this is the sixth smallest. So 0 is the output in this case. So I think it clears what that. So I think now you are clear that what we need in this question. Now let us try to understand few more things. What are the different range of values which are possible for the nums1 array and nums2 array? So the question says that the minimum value which can exist in a particular array, like right now we have -4, -2, 0 and 3. So the minimum value can be -10 to the power 5, that is -1, 0, 0, 0, 0, 0. That's the minimum value which can be there in the nums1 or nums2 array, and the maximum value can be 10 is to power 5. Now if I ask you what is the smallest product which is possible and what is the largest product which is possible, then the answer would be, let us say one scenario is there is a number -10 is to power 5 in the nums1 array and 10 is to power 5 plus 10 is to power 5 in the nums2 array. If you multiply these values, -10 is to power 5 multiplied by 10 is to power 5, then the output would be -10 is to power 10. This is the smallest product possible. The thing is, when you multiply two negative values, let us say two negative values are -2 and -8. Although these are negative values, their product is going to be positive, right? If you want a smaller product, then this can be -2 multiplied by 8. Even though 8 is more than -8, the product of this is going to be -16, right? Which is less than 16, which we got when we multiplied -2 and -8. So the thing is, the smallest product possible is 10 is to power 5 negative multiplied by 10 is to power 5 positive, which is -10 is to power 10. The largest product possible is when both the arrays are having a value like 10 is to power 5 and 10 is to power 5. Then the largest product possible is 10 is to power 10. Now we need to find the kth smallest product. Our answer would be within this range. These are the range of products we have, -10 is to power 10 to 10 is to power 10. Our answer would be within this range, right? Now if I try to solve this particular problem using brute force, no logic, nothing, just complete brute force, then what we can do is we can find all the products which are possible, just like what we did while we were trying to understand the examples. If this is the nums1, this is nums2, find all the products which are possible. Then how can I find the sixth smallest? I can just sort this particular data, sort it and try to return the sixth smallest, right? And the thing is, guys, they might not be sorted. All the products might not already be sorted. We need to sort it. And why they might not be sorted? That's because the numbers are negative and positive as well, right? If you find all the product list for this particular data, this is not sorted, right? It is -8, -4, 0, 6, then -16. -16 is less than -8, right? The data is not sorted. And even though the nums1 and nums2 array are sorted, because the numbers can be negative, the data, all the products are not sorted. So we might need to sort it. So first find all the products and then you need to sort the data and return the kth value. This is very much straightforward, right? But the problem is the question has a bigger constraint. The size of the array can be very large, and when you find all the products, let us say the size of the array is n, and when you find all the products, then it can be n square, right? N multiplied by n. Now if you try to sort this again, then the algorithm would be n square log n square, right? This is too much of a time complexity. Normally n log n is the time complexity in sorting. Right now the value is n square. That's because we are finding all the products. So the number of elements are going to be n multiplied by n. And this is for sure going to give us a time limit exceeded error. And that is why this complete brute force is not going to work. We might need to think something else. Now the thing is, guys, the data, the question says that the nums1 and nums2 are sorted. If they are sorted, then for sure we might need to use this functionality, this particular constraint that the data is already sorted. So there is something we can do with this sorted data, right? If the data is sorted, it's something we can do. Now the first thing is, when the data is sorted and we want to search for a particular value, the best algorithm to search for values when data is sorted is binary search, right? So we can say nums1 and nums2 are sorted. Let us see if binary search can help. Okay, that's what we are trying to do. Now the thing is, guys, we don't need to search in the nums1 array or nums2 array. We actually need to search in the product list, right? We need to find a product nums1 of I multiplied by nums2 of j. So we are actually dealing with a product and not the numbers in the array. And we know the range of possible products, right? It is -10 is to power 10 to 10 is to power 10. Now this is the range we have, and this is a sorted range. This is the lowest value, this is the highest value. So now we need to search for the perfect mid value in this range. This is the range of all the possible products we can get, right? We need to find a value between this range, which is the perfect value for us, for which there are k number of products less than or equal to that mid value. Now let me try to explain you this with the example. In the example, we have to find the sixth smallest, right? Our answer is 0. Now this 0 means that there are 6 number of products which are less than or equal to 0. This is the first, second, third, fourth, fifth and sixth. These are 6 products which are less than or equal to 0, right? If I talk about find the answer for k equal to 7, then in this case you need to find the 7th smallest. 6 is the 7th smallest. There will be 7 elements in this all the product list which will be less than or equal to 6. That's our answer. That's our mid value between the range 1, 2, 3, 4, 5, 6 and 7. There are 7 values, right? So that's what I'm trying to tell you, that this is our range of all the possible products. We need to search for the perfect mid value within this range for which there are k number of products less than or equal to mid. That's what we need to do. So right now we have a search space, right? We already know what is the searching space we have. The left value, the lowest value is -10 is to power 10. The right value, the highest is 10 is to power 10. We have a range, right? We can just run a basic binary search logic to find our answer. And you might be confused that the nums1 array and nums2 array are sorted, but we are not trying to do the binary search here. We are trying to do the binary search in this range. Again, because we need to return the product and not the number, right? So we need to search from all the product we have. We cannot create all the products because that is going to give the time limit exceeded error, but we know the range, right? This is our range. The lowest is this one, this is the highest. So we can search in this range, and we are going to use binary search again later on in our nums1 and nums2 array as well, and I will tell you why we will use it. But right now you need to do a binary search in this range. The basic logic of binary search is we run a loop while we just keep running a loop while the left value, our low value, is less than the right, that is our higher value. This is a basic binary search logic. There is no extra thing which I am trying to tell you. This is a basic binary search logic. You run a loop while the left value is less than the right value, and then you try to find out what's the mid value here. The mid value is left plus right divided by 2. Again, that's some basic binary search. Now we need to find a value. Let us call it as values is equal to check. Let's say there is a function check, and we check for this mid value. Now what we are trying to check, you can answer this. You just need to know what the question is, right? The question is, we need to find for this mid value, how many values, how many products do I have? Because this mid value is nothing but a product, right? This is the range of product we have. We are trying to find out what's the mid value as of now. This is the product which is possible, which is a possible answer, right? I want to check how many values do I have, how many products do I have which are less than or equal to this mid value. Why I am trying to do it? That's very simple to understand. I need to find out k number of products which are less than or equal to mid, right? So if I have a mid value, I am assuming that this can be the answer. So what I will do is I will say, okay, this is my mid value. Try to find out how many products are there using the check function. We will understand the check function later. But using the check function, tell me how many values do I have, how many products do I have which are less than or equal to the mid value. That's what I'm trying to check. Now, once I find the value, let's forget about the check function. We will see it later. Once we find out how many products or how many values do I have which are less than this product, that's mid. And let's call it as values. That's the number of products we have which is less than or equal to mid. In this case, I will check if this values is less than k. Now what is this? Again, this is basic binary search. We are trying to see if this values, let us say we are checking that the mid value is 10. Try to find out if the value of mid is 10, then I am checking how many products do I have which are less than or equal to 10. And if this value is less than k, that is, let us say the values is 5, that is, we have just 5 products which are less than k or less than 10. We need to find the kth smallest, right? Then the possibility is our answer is more than 10. And why so? That's because if mid is 10 and the output of this function is 5, it means that we have 5 products which are less than 10. Let us say the products are 1, 2, 3, 8 and 9. These are the products which are less than or equal to 10, right? We need to find the kth smallest. Let us say the value of k is 8, right? We need to find the 8th smallest, right? This is the 5th smallest. 9 is the 5th smallest, right? So the 8th smallest is going to be more than 9, right? Right now we are checking for 10. Now what we can do is we can reduce our search space. If the number of products, the values is less than k, we will say let's increase the left or the lower value so that we can get a bigger mid value, so that the number of values which we are getting is more now, because we need to find the kth smallest. And if this values is less than k, we need to increase our search space. So the left value is going to be mid plus 1. So the left value will be 11 now, right? The right value will remain the same in this case when the values is less than k. But let us say this values is not less than k. Let us say this values is more than or equal to k. If we are checking for mid equal to 10, right? And we are trying to find out the 8th smallest product. And if this values, let us say this values is 9, right? It means that there are 9 number of products which are less than or equal to 10, right? Let us say the products are 1, 2, 3, 4, 5, 6, 7, 8 and 10. Okay, let us say these are the 9 products we have which are less than or equal to 10. We need to find out the 8th smallest, right? The 8th smallest is going to be 8. That is going to be less than 10, right? Right now we are checking for 10. Then what we can do is we can say let's make the right equal to mid. Let's reduce the value of right, which was earlier something bigger. Let's reduce it and make it equal to mid, so that when we are again trying to find out the value of mid, this will be equal to left plus right divided by 2, right? So the mid value will be reduced to something else. Maybe the mid value will go from 10 to, let us say, 2. Then it will move to 9. Then it might move to 5. Then it might move to 8. And 8 is our answer. For 8, this values will be 8, right? Now when it is equal and this condition ends, we can just return the value of left. That is going to store our answer. How it is possible? Let me tell you. Let us say these are all the products which we have, right? Let's sort it out. Minus 16, minus 8, minus 8, minus 4, 0, 0, 6, 12. Now if I ask you, try to find out the 7th smallest, then you will say it is 6, right? 1, 2, 3, 4, 5, 6, 7. This is the 7th smallest. Now for the demonstration, let's reduce the search space to minus 100 to 100. I know the search space is minus 10 to the power 10 to 10 to the power 10, but this will be very hard to demonstrate here. So I am saying, let us say this is our search space. In this case, the mid value is going to be 0 because 100 plus minus 100 is 0 divided by 2 will be 0. I want to check that how many values do I have, how many products do I have which is less than or equal to 0. So we have 1, 2, 3, 4, 5, 6. We have 6 products less than or equal to 0. So the check function will return 6. Now I want the 7th smallest, right? Right now my mid value, which I am saying that it can be an answer, is having 6 values, 6 products which are less than or equal to it. My value of k is 7. Then I would say, let's change the value of left so that the mid value becomes more, so that the mid value increases. We are setting the left is mid plus 1. We would say the mid is 0. Now the left is 1, 0 plus 1. So now the mid value will be 50. That's because 1 plus 100 is 101 divided by 2 will be 50.5. Let's take the floor value 50. Now I'm asking, check that how many products are there which is less than or equal to 50. So actually all the products are less than 50, right? So I would say 8. That is, there are 8 number of products less than or equal to 50. Now this is more, right? Since this is more, we need a 7th. This 8 is telling me that my answer would be less than 50, right? So I will reduce the search space and I would say this higher value, the higher range will now be reduced. So the right value will be mid. The mid is 50. So now my right value is 50. Left value is 1. In this case, the mid value is going to be 25, and again the check function is going to return 8 because all the values are less than 25. My highest value is 12, right? So all the values are less than 25. Okay, again reduce the search space. From 50 I will go to 25. From 25 I will go to 13 because 1 plus 25 is 26, divided by 2 is 13. 13 means that all the products are less than 13. So this will again return 8. The check function is going to return 8, right? So I will again reduce the search space. My search space will be 1, 13. My answer is within 1, 13. You know the answer is 6, right? Right now we are good. The left is 1, the right is 13. The mid value is going to be 7. 1 plus 13 divided by 2. This is 7. Now tell me, how many values do I have which are less than or equal to 7? I have 1, 2, 3, 4, 5, 6, 7. I have 7 values less than equal to 7. Exactly what I need, right? I don't know this is the correct answer, this 7, and actually the 7 is not the correct answer, right? But we are saying that, let us say the answer is 7, then there are 7 values which are less than equal to 7. We are not going to end our loop. That's because binary search ends when left is more than right or left is equal to right. We are going to run the loop till left is less than right. That's the basic binary search. So we are going to say, okay, fine. Right now this is 7. We got 7 values when the mid is 7. Again, we will reduce the search space because our answer, our maximum answer can be 7 or less than 7, right? Our answer can be less than 7 as well, right? So let's reduce the search space. So the search space was 1, 13. Now it will be 1, 7. The mid value is going to be 4. Now tell me, how many values do I have which is less than or equal to 4? I have 1, 2, 3, 4, 5, 6 values, right? So I have 6 values. Now 6 is less than k. It means my answer is more than 4. Okay, let's make the left mid plus 1. So mid is 4, left is 5 now. What is the mid value of 5 and 7? It is 6. For 6, the value is again going to be 7. That is, if I'm saying my answer is 6, how many values do I have which are less than equal to 6? It is 1, 2, 3, 4, 5, 6, 7. We have 7 values. Okay, fine. My mid is 6 now. I will again reduce the search space because this is 7, which is not less than k. So maybe the answer is less than 6, right? Let us say if the answer is less than 6. So we are going to reduce the search space. This will be 5, 6, right? Right value will be equal to mid. This time the mid value is 5. The number of values which I am going to get is 6. There are 6 values less than equal to 5. This 6 is less than k. Let's increase the search space. This 5 will become 6 here. The left will be 6 now. The right will be 6. The mid is 6. The number of values we got is 7. And now you will see left is equal to right. We run the binary search till left is less than right. So we can stop here. And this is going to be our final answer. Not the mid, but this one. Because this was the last increase we gave to our range. From 5, 6, we moved to 6, 6. This is going to store our answer. Now we know how the binary search logic work, right? The only thing we need to understand is how this check function work, which can check that if I'm trying to search for any mid value, how to find how many values are less than or equal to that mid value. For example, if the mid was 5, the answer was 6, right? I know it is 6, we know it is 6, it is 1, 2, 3, 4, 5, 6 values are less than 5, so it is 6. But how do I find it? Now let's try to understand it again. This is our all the products we have. So this is our product list in sorted order. The value of k is 7 and the answer is 6. That's what we know. The nums1 array is -4, -2, 0, 3. Nums2 array is 2 and 4. Now let me try to explain you how this check function can work. Let us say the mid value is 5. If I am trying to search for a mid value of 5, I am getting the output as 6. How can I find it? What we can do is we can use a little bit of binary search here because the data is sorted. Now see, the thing is the nums1 array is -4, -2, 0, 3. -4, -2, 0, 3. What I can do is, what we can do is we can say, if my nums1 array has a value -4, tell me how many products I have which is less than equal to 5, right? If it is -4, the products are going to be -4 multiplied by 2, -4 multiplied by 4, which is -8 and -16. Both are less than 5. So we got two values using -4. Similarly, we are going to get two values using -2, two values using 0, and no values using 3. So that we can return 2 plus 2 plus 2 equal to 6. But right now we are just trying to create all the products, right? We are not going to do it. We are going to use binary search a little bit smartly here. Now, if my nums1 array is -4, -2, 0 and 3, nums2 is 2 and 4, then one of the logic which we can think about is, instead of finding all the product, what we can do is, let's just run a simple loop in the nums1 array. This is going to fetch -4, -2, 0, then 3, right? Now, when the value is -4, we know that there are two products less than or equal to 5. Because -4 multiplied by 2, -4 multiplied by 4 is -8, -16. Both are less than equal to 5. If I ask you, if the product is 5, one of the number is -4, then what can be the second number to make the product equal to 5? This will be equal to 5 divided by -4, right? Which is -1.25. It means that if one of the number is -4, the second number could be -1.25. So with -4, the other number is -1.25. Now, can you tell me where does this number fits into my nums2 array? it is fitting at this position, right? The index number 0. If it is at index number 0, we can say that all the values in my nums2 array is more, right? This minus 1.25 is at this index. Then all the values, there are two values, right? The length of this array is 2. This is an imaginary value which we are trying to create, but the actual array is 2, 4. So we are trying to find out this value fits here. Then there are two values more than nums2 array. Now you need to understand a very important thing. This is a negative number, right? If this is a negative number, if you multiply a negative number by let's say 1 and a negative number by let's say 2, this 2 is more than 1, still the product of minus 4 and minus 2 will be less than the product of minus 4 and 1, right? That's because if you multiply a negative number with a lower number, the output is going to be more than you multiply a negative number with a higher one, right? So if my 1.25, negative 1.25 fits here, it means that if you take a product of minus 2 with all these three values, this is an imaginary one we put here, then this value will be the highest, right? This value will be less than this value will be less than this, right? So from here I can say that if I have to search for a particular product, that how many values are less than 5 when one of the element is minus 4 and the other elements are coming from the nums2 array, both these values are less. Both these products with this value and this one is less, right? Less than 5. How can I say this? If my number is negative, let's try to understand about just the negative scenario. If my number is negative, if my one number is negative, other number is minus 1.25, it is fitting somewhere here, then I can say the position here is 0. The number of data in my array is 2. 2 minus 0 is 2. There are two values, two products which will be less than 5 if my number is minus 4, if one of the number is minus 4. Now how can I find where does this value fit here? We can just use a binary search, right? We can just binary search in this array because it is sorted. Since this is sorted, we can search for the perfect position of minus 1.25, that where does minus 1.25 fits here. Now the thing is guys, if the value is minus 1.25, let us take the higher value in this fraction. The higher value is going to be minus 1, right? Then reduce minus 1 from it, then it will be minus 2. Now I am trying to fit this minus 2 in this array. I am going to tell you how this formula is coming up. Don't worry about it. Let's just try to understand the basic thing here, that if this is minus 2, we are fitting minus 2 here. All the two values are more, and since the number is negative, if it would have been positive, the scenario would have been different. But since this number is negative and the other product is fitting at the 0th position, then the number of values less than this product 5 is going to be length of our nums2 array, that is length is 2 minus the position 0, and that is how we can find it is 2. And if you didn't get it, let's try to understand it with minus 2 as well. With minus 2, if this is your number, how many products can you create using the nums2 array which is less than or equal to 5? The answer would be 2, right? Because minus 2 multiplied by 2 minus 2 multiplied by 4 both are less than 5. Again the same formula, 5 will be divided by minus 2, the value will be minus 2.5. This minus 2.5 is going to fit somewhere here in my array, right? Using binary search, we can easily find out without looping in the whole array that which position minus 2.5 fits. It is fitting here, right? At the 0th position. It means all the other elements are more than this value, minus 1, minus 2.5. It means if you are trying to create a product with minus 2, all these two values are going to create values which are less than or equal to 5. Because it is negative, right? If you multiply a negative number with higher number, the product is going to be lower. This minus 2.5, you can just take the ceiling value of it, it is minus 2, then minus 1 from it, this is minus 3. Again, I'm going to tell you how this logic is coming. For now, you just need to worry about this. Now, when the number is 0 and you are trying to search for, let us say minus 5. Instead of 5, let us say you are searching for minus 5. When the number is 0, when this is 0, if you multiply 0 with any number, all are going to be 0, right? If it is 0, all are, and the products are 0, right? So basically, when all the products are 0 and you are searching for minus 5, then you have no products which are less than or equal to minus 5. So when it is 0 and the product you are searching for is negative, you can say you have 0 values which are less than or equal to your product. But when it is 0 and you are saying that my mid value is 5 which is positive, then you would say I have the length of nums2 array, number of elements which are less than or equal to 5. That's because if you multiply 0 with any number, it is going to be 0, 0, 0, 0, 0, right? You have two numbers, 2 and 4. The products are going to be 0 and 0. Both are less than 5, right? So this is 2. Now, if the number is positive, it is positive, right? If it is positive, 5 by 3 is 1.67. Where does 1.67 fits? It fits somewhere here, right? At the 0th position. Now, when the number was negative, we are saying that if my other number is fitting at 0th position, I'm getting two values, which is the length of my nums2 minus the position, right? But when the number is positive, when you multiply a positive number with smaller number, the product is small. When you multiply a positive number with bigger number, the product is large. So if the position is 0, you have 0 number of elements for which the product will be less than equal to 5. The products are 3 multiplied by 2 is 6, 3 multiplied by 4 is 12. Both are more than 5. There are no values less than equal to 5, and that is how we are getting 0. So our main concern is try to find out the other value using which when you multiply your number in the nums array, the product is 5. And whatever is that value, when it is negative, we are going to deal it differently. When it is positive, just make sure that you just take the floor value of it. Okay. You cannot take the ceiling value. If you take the ceiling value, this will be 3 multiplied by 2, which is 6. And you might say that if it is 6, then the products you have is 3 multiplied by 2 is 6, 3 multiplied by 4 is 12. And when you are taking the ceiling value, which is 6, then you are actually getting one value which is less than equal to 6. But in reality, the product is 5, right? There are no values less than equal to 5 when one of the number is 3. And that is why we are taking the floor value when this is positive. And this is how we are just trying to say that just try to find out the other value using first value in the nums array if you already know the product, and try to fit the position of this value in your nums array, in your nums2 array actually. And once you have the position, you just apply the formula. If this is negative, then it will be length of nums2, that is whatever number of elements you have, minus position. That's because when the other number is negative, a negative number produces a bigger value with a lower number. When it is 0, I already told you, if the number is negative, if this product is negative, you will get 0 values less than equal to minus 5 or minus 10 or a negative number. But if it is positive, all the products are going to be less than your positive number. And now when this is positive, in this case, you find the other number with the position. That position will tell you how many number of elements or how many number of products you have less than equal to 5. Now, I know that you might be clear for positive and 0 case, but what about negative? Why are we using this formula? Let me tell you. Let us say we are trying to search for two different values, 5 and 6. Now, if this is my array, minus 3, 2 and 4, and one of the number is minus 2 in the other array. Now, let us say this is my nums2 array. This is nums2. Okay, this is nums2. And this is one of the number I have in the nums1 array, minus 2. Then the products are 6, minus 4, minus 8. With 5, there are two elements less than equal to it, right? And with 6, there are all these elements which are less than equal to it. Now with 5 and with 6, if I apply the formula that what is the other product which I should have, if one of the number is minus 2, what is the other number I can have, so that I multiply it and get 5 or 6. So it will be 5 by minus 2, 6 by minus 2, which is minus 2.5 and minus 3. Now the thing is, if I'm just saying that I convert this minus 2.5 to minus 3, let the lower bound. For minus 3, it will already be minus 3, right? Now this minus 3, where does this fit? It might fit here, right? Minus 3. Right now we are not applying the formula. Then this minus 3 will fit here. And it is telling me that the position is going to be 1. This is 0, this is 1, this is 2, this is 3 in my nums2 array. If the position is 1, then for 5 and 6, the values are going to be 1. And if this is negative, then the formula is length of nums2 minus the number of position. So position, right? Length is 3, 3 minus position is 2. So for 5 and 6, for both of them, the answer is 2. But for 6, the answer should be 3. There are 3 products less than 6. For 5, there are 2 products which are less than equal to 5. And that is why we are saying that you just take the floor value of it. Take the floor value. This will be minus 2, this will be minus 3. Then again take a negative. If you take a negative in both the scenarios, this will be minus 3. For this, it will be minus 4. For 5, this is minus 3. It is going to fit here. The position is 1. So the number of elements you are getting is the length of nums2 minus position, which is 2. For 5, the answer will be 2. For 6, this is minus 4. It is going to fit somewhere here. The position of minus 4 is 0. This is 0. This is 1. This is 2. This is 3. So the position is 0. So the number of elements less than equal to 6 is length of nums2 array, which is 3, and the position, which is 0. Then it will be 3. So there are 3 elements less than equal to 6. That's how we are trying to solve this question. And I know, guys, this is very complex, but that's completely fine. The question is hard, right? So it is going to be complex. And even I am sure that I have explained you so much, still you might have a lot of doubt. I can say the doubt will only go when you are actually trying to solve or trying to understand it using dry run. That is, take some input, try to solve it on paper, and then only you will be able to understand. Now let me explain you the code for this particular problem. This is going to be very simple. What you are going to have is, you are going to say left comma right is going to be your leftmost range and the rightmost range. Then you run a simple binary search logic. By left is less than right. Mid will be this value. Left plus right divided by 2. Then you check that for mid, if the value is less than k, left is equal to mid plus 1, else right is equal to mid. And once you come out of the loop, you will just return the value of left. This is the basic binary search. Now we need to understand about the check function. For check, we would say check for the mid value. Right now the total is 0. We just run a simple loop in the nums1 array, and we say that if n1 is more than 0, then the total will be total plus bisect nums2 comma mid divided by n1. The thing is, this bisect is nothing but this try to find out what is the position at which this value is going to fit in this array. That's what we are trying to find out. So this is something which is available in Python. If it is not available in your programming language, maybe in Java or some other language, then you might need to implement this functionality, and this can be implemented using binary search because the nums2 array is sorted. Now if the value is less than 0, if n1 is less than 0, then you will first find out the position, which is equal to bisect nums2, then take the ceiling value of this value, mid is divided by n1, and then take minus 1. Then the total is going to be total plus length of your nums2 array minus position. I have already explained you this formula. And else, if the value of n1 is 0, in this case we are going to say if mid is more than equal to 0, then we can say total is equal to total plus length of nums of 2. And then you can just return the total number of elements. This value of total is going to be used here. Now you can just submit this and this is going to pass all the test cases for this particular problem. And this is actually a very efficient solution as well. You can see the runtime is pretty good. The memory used is very good, right? So we have solved this particular problem. Let me scroll this to show you the complete solution in one screen, right? So this is the complete solution for this particular problem. Now, guys, I think that's it for this video. I know it was very large, it was a big video, but I hope this video explains you at least something about this question, the solution approach, and the thought process behind this problem as well, behind the solution as well. And if it did, then make sure that you hit that like button, because it was actually very hard to make a video on this particular problem. So it took a lot of efforts. So make sure that you hit that like button to appreciate the efforts. But if you have some questions, if you have some doubts, then make sure that you put it in the comment box as well. You don't need to hit that like button. You can just put the comment and I can answer you for whatever query you are having. And if you have not subscribed to the channel, then make sure that you subscribe to the channel as well, because we are very close to 1000 subscribers. And I think once you subscribe to the channel, you will get regular updates on different Leetcode questions, creating APIs, creating Flask project, Django project, PyTorch project. So there are a lot of things in my channel. You can check it out. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this video, guys.